Hi everyone, Tony Durrant here. I've got an Ecko U245 radio here, and all it does is produce a little bit of a hum, so I thought it might make an interesting video just to sort of work our way through it. One of the things I wanted to show you actually is the case, which was quite interesting really, because if you look at the way the feet go on, you have a chassis screw here which goes in there, and the foot goes on there, and the idea is clearly that the foot should hide that chassis screw, and it's a bit of evidence to show that somebody's been thinking about health and safety here, that it's not a good idea to be able to access the chassis screws. So I thought that was quite good. That's the first thing. Now, leaving that aside, let's get down to business. Let me just zoom up on the camera here a bit. One of the things that it's nice to know before you turn the radio on are all the valve filaments okay. Now in this radio all the valves are connected in series. There are no scale lamps, so therefore I can just check right across the mains, and I can see it doesn't really matter what reading you get. I've got about 1.6k there. If I just pop out one of the valves, see, it's gone to an open circuit, and that shows me that all the valve filaments are okay. It's possible one of them short circuit, I guess, but I've never found one yet. If anybody has ever had a valve filament go short circuit, that would be interesting to know. Anyway, so I've got that. What we'll do now is we'll plug it in and just have a bit of a look. As I say, I know that I get a little bit of a hum out of it, but that's about it. So I want to find out if I've got HT now. It tells me I should have 205 volts. Just while that's warming up, one thing I did notice about this radio is it's very, very smelly. There's a lot of dust on there, and I suspect that's what it is. So I'm just taking a bit of caution with my lamp limiter here, not running it too long on full volt, because I'm just not quite sure what is going on. Here comes the HT. This is with the lamp in series, so that's 160 odd volts, 195. Yeah, that seems about okay. Next thing to do, let's just check on the output transformer. Let's see whether the valve's taking any current. If I look on one side of the output transformer, that is there, 158. Look on the other side, 177. So there's a few volts across the output transformer, which means it is taking current, but I'm not hearing anything. It's just a very slight hum. So, and it is pretty smelly actually, which is quite interesting. So let me turn off. I think what I want to know now is, does the output stage work? I think I'm going to try and put a signal into it. The ideal place for that is across the volume control. I think it's probably worth me just checking that there are no DC volts on there, because I don't want to blow up. I don't want to blow up my the signal generator. So let me just find. Then let's just turn back on again. Just check there's no DC volts across there. Give it a moment to warm up, and just check that I'm on. That was a crackle. I heard something then. No volts DC that side, and I think this side. Oh, look at that! It's on the wrong side. Minus 0.4 of a volt. Okay, but I know the output stage works. There's a hum. So I don't need to put a signal generator in. I know the output stage works. I think the next thing is, let's see whether the local oscillator is working. I'm going to need a scope for that. Okay, local oscillator. So we want to have a look on the grid of the mixer valve, which is V1 here, and I'm just going to find that. It's a 47k resistor, so it's on R4 there, and there's my local oscillator, and I can tune it. Now it's not a very good wave shape for the minute, yeah, but never mind. And that's clearly medium wave, that's clearly long wave. Okay, but I don't hear anything, which is interesting. Right, let's turn off. I'm looking at the control grid of V2 now, and this is the IF amplifier valve. The IF frequency on here is 470 kilohertz, and the local oscillator will run at whatever radio station you're trying to pick up plus 470 kilohertz. Now out here in this shed I can seem to pick up radio 4 and long wave, which is 198 kilohertz. So 470 kilohertz plus 198, 470, 570, 670 is about 668, 670 kilohertz, which is what I've got this set to now. And I'm looking on that grid, and I think I can see radio 4 there, because I can tune through it. And I think that that is the local oscillator and the input signal together, and I can tune through it, and it peaks at around 680 odd kilohertz. So I think that's what it is. But if I look on the anode, scope is AC coupled now, by the way, folks. Look on the anode, practically nothing. So I'm beginning to suspect V2 might be faulty in some way. So I think we'll just have a look at that. Let me turn this off, just make sure. Okay, so I've zoomed out now. Let's see what we can turn this thing over. It is still very smelly, this. I'm still a bit concerned about that. But let's pop. Oh, right. Now let me show you this. Oh, if I can get this thing out. There it is. Hold it up to the camera. Don't know if you can see, but it's white, and what that means is very probably that it's lost its vacuum. So I've got to scrabble around to see if I've got another valve. I think what I'll do actually is I'll show you this on my valve tester. Yeah, let me do that. This is the valve tester, guys. The last thing I want to do is give you the impression that you need one of these things for repairing radios. You really don't. You know, if the filament's gone open circuit in the valve, you can test that with a meter or the way that I did it. If the cathode's gone short circuit to the heater, you can test that. You really don't need one of these things. So this is a luxury. This is a nice thing to have. I was very lucky. I had this one given to me, not quite in this state, I hasten to add. It took me a little while to get it up and running, but it was well worth it. It was a very fun project. But I thought I'd just run through and show you what, you know, let's find out together what this valve actually does. When you set up one of these valve testers, it comes with a book, of which I have here, and you have to set up various parameters. I've just got a little card underneath it, not that you can see it, but you set up the pin connections, you set up heater volts, anode volts, screen volts, GM, you set up negative grid volts. So I'll set all of that up, and you just run through a few things. The first thing you have to do is set this valve tester to the precise mains voltage, and there's a little mark on the scale here, and it's just switching various tappings on the mains transformer to get it spot on the mark. So you have to do that first, which I have done. Right, so having done that, check C, that's the cold check. So the valve heater is not on at the moment, and what you're trying to do is check to see what the insulation is like, or continuity of the heater, depending on what one you're on. So just move that to heater there, tells me I've got continuity, and then you just go around these other pin connections, and already looking at the cathode, looks like a bit of a problem here, because I'm reading about 5 megs and it's reducing. Looking on the grid, you know, I would expect this needle to be sort of right off the scale here. So it was already something very, very dodgy going on. So we'll put it back to that one. This is a hot check, so this is now heating up the heater, and it straps all the other pins together, and it's just checking insulation between all the other pins and the heater. And again, you know, I'm seeing, well, 10 megs, 25, it's actually reducing now as it's warming up, which is interesting. But you know, again, I would expect to see this right off the end of the scale. I don't want to see any conduction here at all. This is cathode to heater. Again, well, it's not bad, but there's something going on. And then you do the test. So you put it on test, and I'll expect to see some anode current here. And it tells me in the book here that I should see about 7.2 milliamps. Well, okay, let's increase the sensitivity. So I'm on a 10 milliamp scale. If I reduce grid volts, I would expect to see some anode current, but I'm seeing absolutely nothing. So that valve is a goner. Right. Okay, so I've scrabbled around in my grotty box and I've found another valve. So let's see what this one does. So heater's continuous, cathode high resistance, grid screen, anode quite high, that's alright. Let's do hot check. So we just leave the valve to warm up a moment, make sure nothing nasty happens. So you've got high resistance between heater and cathode. No, heater and all the other pins, beg your pardon, heater and all the other pins. This is heater and cathode. That's good. Right, let's see whether we get any anode current now. There we are, there's some anode current there. I'm looking for about 7. Right, okay, there's about 8. And you can see, as I move the grid volts, so I'll put that back on 3. Now what you do to find out what GM is, first of all, we'll just back this off here. A bit too much there. You put that on there, so you back that off to 0. You got a MA per volt, and you move this onto right onto the calibration mark in the good setting, and it tells me that the GM there is about 2.25, and it quotes it as 2.3, pretty much spot on. That, I believe, is a good valve. So the next thing to do is put it back in the radio and see if we can get any sound out of it. Right, well, moment of truth. Let's see if we can get anything from it. We just got to wait for that to warm up a moment or two. Here we go.
Although from a distance, some of the rest of the team, although for the time being I am sat in a car park.
That's radio 4 on long wave. Let's see if I can get it on medium wave.
So just a reminder, we're off there a little bit early.
It's really for you to look forward to over the weekend. Six Nations match in England.
Okay, that's very encouraging. Right, so the thing for me to do now is a damn good clean up. I want to try and get to this bottom of whether it's smelly or not, whether something's burning or not. I'll change the X capacitor, give it a good old clean up, and we'll come back when that's done. Well, it's all back together now. I haven't done very much to it apart from give it a good clean inside. Clean the volume control, but it wasn't bad. Clean the wave change switch. A lot of dust on it, but didn't seem to be too much of a problem. But works really well.
BBC Sound. This is BBC Radio 5 Live.
We're at Radio 5. There we go. And long wave. So there's your Radio 4. So I'm very pleased with that. It's cleaned up nicely. I wonder if anybody knows, because I don't know, does anybody know why they used to calibrate scales in wavelength and now we talk about frequency? If anybody knows, let me know, because I'd like to know. You have to kind of work it out what the frequency is that you want. Yeah, very pleased with that. It's cleaned up nicely. I love the kind of minimalist design of this radio. Very little to it. You've got a volume control and you've got a tuning control and a waveband switch, and that's all you get. And I'm very happy with that. I'm very pleased with that radio. Right, well, I'll be doing another video at some point. Don't know when. We'll see you again then. Bye now. Earlier on, when I decided that V2 had failed, I looked at the grid, the input to V2, and I reckon that I could see the oscillator frequency and radio 4, and it occurred to me that a better way of looking at that is to put the scope in FFT mode. Now, the resolution of this scope won't allow me 298 kHz, but it will allow me to 200, which is pretty close. So for the moment, let's call it 200. And what I've done, I've spaced these two cursors 200 kHz apart. I've got to try and do this without putting my hand in front of the screen. And if you look, cursor A is on 470 kHz and cursor B is 670 kHz, a difference between 200 kHz. So 670 kHz, the right hand one is the local oscillator frequency, and the cursor 1, 470 kHz, that's the IF frequency. I'm just going to move the cursors very slightly, just so you can see, because the cursors just tend to cover up the signal, but you can see the right hand one there, cursor B, that's a local oscillator, and cursor A is 470 kHz.